What we're talking about today is lesson 16, simplifying and evaluating variable expressions. To evaluate an expression that contains variables, we will substitute each variable in the expression with a given numeric value and then simplify. Example 1 says to evaluate each expression for the given values of the variables. So for A, they want us to substitute. Instead of A, they give us 5, and instead of P, they give us 7. So anytime that we substitute, it's very, very important to always remember that when we substitute for a variable, we always use parentheses. So I have negative. Instead of A, I will put 5, bracket, negative. Instead of A, I will put 5. And then instead of P, I will put 7, minus, instead of A, I will put 5, and then I'm going to close all of it up. So whenever we're doing this, once we have our substitution done, all we have to do is follow our order of operations. So parentheses, we have to start with our innermost grouping symbol, which is right here. Okay, 7 minus 5 gives us 2, and we're going to bring everything straight down the way that we see it. Once we're here, we need to simplify inside parentheses again. Remember, brackets are another type of parentheses, another type of grouping symbol. So we have negative 5 times 2, which gets us a negative 10. And then out here, this negative and 5, that just gives us a negative 5. So negative 5 times negative 10 is going to give us a positive 50. This is our final answer. And notice that wonderful tornado that we have leading us to our final answer. On example B, it's the exact same thing. I would like for you to go ahead and pause and try and do this one on your own, just to see if you make any mistakes. So go ahead and pause, and we'll go over it together in a moment. On part B, we're going to do the exact same thing, but again, we're going to substitute A as negative 8, and X will be 14. So I have parenthesis minus, instead of X, I put 14, close it up, plus, instead of A, I put negative 8. Here's a good reason to keep those parentheses, because this lets me know that I have two symbols here. If this was a negative and I just put another negative, it might just look like one big negative if I don't have very good handwriting, or I might just forget that there's two negatives and think I've made a mistake, something like that. So I'm done with that first set. Minus X, I have 14. Minus, here's what I'm talking about. We have a double negative here. We want to make sure that we notice that there are two signs there, and this parenthesis lets me see that there's two signs. So now all we have to do is follow our order of operations, which, remember, is our PEMDAS, parentheses, exponents, multiplication and division from left to right, and addition and subtraction. Okay, so parentheses, we have two sets of parentheses that are separated from each other. So that means I can simplify within them first. So I have negative 14 plus a negative. Remember, those are opposite signs. So that gives me a negative. I have negative 14 minus 8 is going to give me a negative 22. Minus, on this side, I'm going to do the exact same thing. But this time I have 14 minus a negative gives me a positive. So that gives me just 22. This negative came from here, remember, and this was a positive 22, so I just brought down 22. Negative 22 minus 22 is going to give me a negative 44, final answer. Evaluate each expression for the given values of the variables. Same thing is going on here. Instead of C, I'm going to substitute 3. Instead of B, I'm going to substitute negative 1. And then I have the quantity of A, which is 2, times B, which is negative 1, times C, which is 3, and that C is being squared, and that's in that parenthesis. Again, order of operations, we do parentheses. Inside these parentheses, I have exponents, so I have 3 to the second power, which gives me 9. And I'm going to bring everything else straight down. Oops, I'm sorry. This is a -1, not a -3. I wrote the wrong thing. My mistake. And 3. At this point, all that's happening is all of this is being multiplied. So I'm just going to multiply from left to right. I'll go inside my parentheses first so that I'm being technically order of operations correct here. So I have 2 times -1 is a -2. And then I'm multiplying that by 9. Bring down my other stuff. So I have -2 times 9 is a -18. Bring down everything else. 3 times -1 is -3. 3. My computer must be acting up here. -3 times -18. Negative times a negative gives me a positive, and I'm just going to bring my answer over here. 3 times 18 is going to give me 54. Final answer. So if you would pause and try and do part B on your own. Part B, we're going to do the same thing. We're substituting again. So we have x is -1, y is 3, and then times a quantity of 7 times z, which is 2, all over x, which is -1, it's being squared, times y, which is 3. Now, whenever I have this division bar, it's very important for you to remember that this division doesn't follow order of operations until everything on the top is simplified and everything on the bottom is simplified. So I'm going to simplify on the top first, and on top I'm going to multiply inside these parentheses first. So I have -1 times 3, and then inside those parentheses is 7 times 2, which is 14, all over. -1 squared is a +1 times 3. I can simplify at the same time on the top and on the bottom because nothing is happening between them until that division step. So then I have -1 times 3, which is going to be -3 times 14, over 1 times 3 is 3. -3 times 14, okay, negative times a positive is a negative. And then 3 times 14 is going to give me 42. And then 3 is on the bottom. When I divide this, I get negative, because negative divided by a positive is a negative 14. You could have also seen that 3's will cancel here. Same thing. Simplify each expression, then evaluate. Okay, it wants us to simplify first. So that means that we need to get this in the simplest terms possible. So what it's asking us here is that this negative x can be distributed to everything on the inside. Okay, so I have -x times y is -xy. Negative times a negative will give me a positive. And then I have 3 times that x, which is 3x plus y. Okay. I can't simplify this any farther because I don't have any like terms, so now is the point that I can go ahead and substitute. I have negative, instead of x, I'm going to put 0.75 times y, which is -2.5, plus 3, instead of x, I'm going to put 0.75, plus y is a -2.5. So I have a -0.75 times -2.5, and negative times a negative I know gives me a positive. 0.75 times 2.5 will give me a 1.875, plus, these are both positives, so 3 times 0.75 will give me a 2.25. Plus that -2.5. Now all I have is addition, which I'm going to do from left to right. You can also think of it as addition and subtraction because these two signs we know is going to give us a negative, but still it's just addition and subtraction, which we work from left to right. So when I add these two, that gives us 4.125. And then I'm going to subtract that 2.5. because of our sign change there. And that's going to give us 1.625 as our final answer. On B, go ahead and pause. I want you to simplify before you evaluate. That means simplify before you substitute. Alright, so part B, we're going to take x to everything inside. So x times x gives me x squared, plus 2y times x is going to give me 2xy, minus x. Same situation here. I don't have any like terms because for them to be like terms, I must have the exact same variable with the exact same exponent, and I do not. So I'm going to go ahead and substitute at this point. Okay, looks like I have a little exclamation point here. I apologize. X is 1/3, so I'm going to substitute 1/3 in parentheses. It's being squared plus 2 instead of x. Again, I have 1/3 times y, which is 1/2, which I put in parentheses as well, minus x, which is 1/3. Okay, that is a parenthesis I just looked for. Okay, so order of operations, I'm going to do my exponents here. 1/3 times 1/3 gives me 1/9. Plus, I can go ahead and, because of this addition and subtraction, those separate terms, so I can go ahead and simplify within each term. So 2 times 1/3 is 2, and 2/3, excuse me, times 1/2 minus 1/3. Okay, so that took care of this part, and this is right here. 1/9 still doesn't change. Plus, when I'm multiplying these two, this is going to cancel because this is in the numerator, this is in the denominator. I can cancel over that multiplication. So I have 1/3 minus 1/3. So now I have to follow my order of operations, which is addition and subtraction from left to right. I know that 1/3 is the same as, I'm going to cancel this out and call it 3/9 instead. I have to have a common denominator. So 1/9 plus 3/9 is 4/9 minus 1/3, which we just said was 3/9, which gives me 1/9 as my final answer. This is just a fancy way of saying evaluate the expression using these variables. So it says if v is -3 and z is 6, what is zv to the third? So I'm going to just substitute like I have been. Instead of z, I'm going to put 6. Instead of v, I'm going to put -3, and that's to the third power. Whoops, don't forget those parentheses. It'll change your answer. Now I need to follow order of operations. -3 to the third power. It's very important if you're using your calculator that you punch it in exactly the way you see it. If you don't, it will be wrong. So it's parenthesis -3, not minus, negative. Use the negative symbol. Close the parenthesis and then caret 3 to get that exponent of 3. And that's -3 times -3, which is +9. +9 times -3 gives us a -27. Times that 6 gives us -162. Final answer. Okay. B, go ahead and pause and try to work it on your own. B wants us to evaluate if m is equal to 5. So these bars, even though they look really poor, those are actually absolute value bars. Okay, it's just the way the program types them out. So I have the absolute value of -m, which is 5, and that is to the third power. So I have, this is just going to give me -5. So I have the absolute value of -5 to the third power. Well, I can punch that into my calculator as parenthesis -5 caret 3. That gets me the absolute value of -125. And the absolute value is the distance from 0. Okay, remember it is not the opposite. It is the distance from 0. And -125 is 125 units from 0. That's our final answer. Last example here. A savings account increases as interest accumulates according to the formula, and a piece of y equals 1 0.04 times the quantity of P sub y minus 1, where P sub y is the principal balance at the end of y years, and P minus 1 is the principal balance after y minus 1 years. After 6 years, there is a principal balance of this much money, which is $1,450. How much is the principal balance after 8 years? So what you need to do is, we know what it is after 6 years. Okay? We know that P sub 6 equals $1,450. Okay, but in order for us to find what it is after 8 years, we also have to find what it is after 7 years. So to do that, we're going to have to use our formula here. Okay, so what we know is that P sub 7 would have equaled 1.04 times the quantity of P sub 7 minus 1. Well, P sub 7 minus 1 is the same as saying P sub 6, which we already know. So instead of P sub 6, we're going to plug in, or instead of P sub 7 minus 1, we're going to plug in P sub 6, excuse me. So I have 1.04 times the quantity of $1,450. So whenever I do that, I have 1.04 times 1,450, and that gives me that P sub 7 is equal to $1,508. And what I'm going to do is, I'm going to take this and I'm going to use it to find P sub 8, because that's what I really want. I want to know after 8 years. So I know that the formula for P sub 8 would be equal to 1.04 times the quantity of P sub 8 minus 1. Well, P sub 8 minus 1 is the same as saying P sub 7, which I now know. So I'm going to take this value and I'm going to plug it in here. So I have P sub 8 equals 1.04, and instead of P sub 7, I'm using this value, which is 1508. And when I multiply that times the 1.04, that is going to give me P sub 8, or after 8 years, the principal balance will be $1,568.32, which that looks like a 3.32 cents. Final answer.